Hello and welcome to part 1.5 of Flat Earth Answer to Jeranisms Curve Dilemma. This is actually a response to a poster's comment, a Robert Mayer, who pointed out that we are not measuring the arc distance of the curve, which is the distance that an object is away from the viewer. We're measuring along the tangent, which is a it's a different number than the arc distance, or the distance to the object. Now, over the first 100 miles or so, there isn't enough difference to make the answer any different. So your tangent and your arc distance are about the same over the short distance, but over the far distance, they can be quite different. So we're going to find out what true curvature is here. So using the tangent distance of 3,960 miles, drop along the hypotenuse of 1,640 miles, plots this point here. And what we need to do is find out what is this distance. And in order to find out what this distance is, we need to know the arc measure. Well, this being a perfect square, and representing 1/4 of a circle, this distance is 1/8 of the circumference of that circle. So if we take the circumference of the circle, 24,881, plus the decimals, they are included, and divide it by 8, we arrive at 3,110 miles, 0.176728. And we plug that arc measure into this little equation here. Now, these math equations are going to be a part of a second video posted in the comments by somebody else who did a very good math video describing the tangents, distances, arc measures, all of the mathematics involved. It's a very good video. So in order to determine the value of the measure of this angle, angle x equals 180 times the arc measure, which we know is 3,110, divided by pi times the radius. Now, as it turns out, again, this is a perfect square. This is the diagonal on the square. So we can know that the measure of this angle is 45. Doing the math, I did the math, it came out to just over 45, but that depends on how many decimal places it carries out. It is actually 45. So it gave me some erroneous answers, but it let me zoom in on the correct answer doing it this way. So we have a 45-degree x, and we plug it into the formula where this drop distance equals r times 1 minus the cosine of x, or cosine of 45. And when you do that, the distance of drop is 1,159.857151, 1,160 miles. Excellent. That is the drop in curvature along an arc distance of 3,110 miles. What we don't know from this point is what's the tangent point. And this is the tangent point based on the vertical drop, which is this equation here, r minus the square root of r squared minus t squared. So the solution to that is to take d, which we now know as 3,110. So the 3,110 equals the radius minus the square root of r squared, which we know, minus t squared, and you solve for t. That's a toughie. Go ahead and do it if you would like. For this particular equation, because this is the hypotenuse, it is also on a 45, and it creates a 45, 45, 90 triangle. We can apply a squared, distance, plus b squared, which are then equals c squared. So we can take 1,640.28757, square it, divide by 2, and then take the square root of that, and we come up with 2,800 No, we don't. We come up with, we don't come up with 2800. We come up with, what is the measure of that? 1,159.857,151. 1,159 miles. The length of this measure here. Well, that's also the length of this measure here. And so we simply subtract 1159.857,151 from the distance of 3960, and we come up with a tangent distance of 2,800 miles. So, all in all, at 2,800 miles, and let me show you that we've got it here. At 2,800 miles, vertical drop at 2,800 miles, and there's the formula for it, is 1,159 miles to intersect at the arc measure of 3,110. So 1159 is, or 1,160 miles, is the drop rate, is the curvature, vertical curvature, for an object 3,110 miles away from your starting point. And there it is. I hope this answers your question, Robert. And again, if we look at, and I did some distance comparisons, if we look at the miles, distance miles along the hypotenuse for various radiuses of circles, from 3,955 miles up to 3,965 miles, you can see that the difference is very slight even for all of those variant sizes of circle. But also, as you go distance out, the difference is also very slight over the short distance. Over 12 miles, there's only a difference of between 96.12 feet and 95.878 feet. A very minimal difference. And this is measuring along the hypotenuse. Now, measuring along the vertical drop, our measures of 96 feet, 0.121 feet, very similar, and 95.879, very close, and the differences are negligible. And realizing that the arc measure is between this and this for our circle. And I've used 3960 as my circle because it most closely represents 8 inches per mile squared. And that is something interesting. That 8 inches per mile squared comes out first, and you can determine 3,960 miles radius from this measure. And this measure is 3 miles visibility squared times some value at a 72-inch drop. So 3 squared is 9. Divide both sides by 9. We have x equals 72 divided by 9. X equals 8. This is based on our visual 3 miles distance out with a 6-foot drop. The difficulty comes in is we see at 3 miles out a 12-inch rise, or 6-foot rise, 72-inch rise, not a 72-inch drop. So that, well, I'll investigate that in a little bit. But as far as answering your curvature question, I hope that has solved it for you. I don't have an easy equation, and in order to find these points and their various drops, you need to calculate the value of the measure of the arc here, x arc, measure of this here. I don't have an easy way to do that. If you do, go for it. Thank you for watching, and stay tuned for part 2, where we cover what you can see at a distance. Thank you.